These are your instructions. In general, you just need to follow a PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. On some of the slides, there are instructions for you in the yellow boxes. And don't forget, if a slide asks you for homework, send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given.
Starter activity. Can you recall Newton's first and second laws? This is Newton's first law. An object will remain stationary or will continue to move at a constant velocity unless a resultant force acts upon it. And you need to be able to recall that, so please memorize it. This is Newton's second law, and again you need to memorize this. The acceleration of an object is proportional to the resultant force acting on the object and inversely proportional to the mass of the object. And if we were going to write that as a formula, we would write F equals ma, force equals mass times acceleration. This lesson is all about Newton's third law. By the end of the lesson, you should be able to recall Newton's third law, and you should be able to use Newton's third law to explain different situations in which objects are in equilibrium. This is how Newton's third law is usually stated, and again, you should memorize this. Newton's third law states that when two objects interact, the forces they exert on each other are equal and opposite. And another way that you often hear it phrased is every action has an equal and opposite reaction. So let's have a look at an example of Newton's third law in action. So here we have a man in a canoe paddling. As he paddles, he's using the paddle to push back on the water. But at the same time, the water is pushing back on the paddle, and that is what is giving him his driving force forwards. These forces are equal in size, but opposite in direction. Here's a second example. When a car is driving along the road, each wheel is exerting a force pushing back on the road. But at the same time, the road is exerting a forward force on each wheel. And again, these forces are equal in magnitude or size, but opposite in direction. Third example. When a rocket fires, the chemical reaction from the fuel produces a downward push force on the exhaust gases. These hot gases produce an equal force on the rocket, but acting in the opposite direction, i.e. straight upwards. Have a look at this BBC bite-sized video, which explains Newton's third law using the idea of skateboards. Now, students often get confused with this idea of Newton's third law, and this is what causes the confusion. If all of these forces are equal and opposite, how does anything ever move? Surely, if you've got a force acting in one direction and a force acting in the other direction, the object's going to be at equilibrium. And the key to understanding it is to remember that we're talking about two objects. The equal and opposite forces are acting on two different objects, so it will affect them differently. And a good way to try and memorize this is to think about a hammer and a nail. Now, at the point where the hammer hits the nail, there will be the force of the nail on the hammer and the force of the hammer on the nail. They're equal and opposite forces. But because they're different objects, that force will affect them in different ways. They're different objects, they have different masses, different shapes, etc. So the force will affect them in different ways. The key thing to remember is that you're talking about two different objects. Now, although it looks very different, exactly the same set of rules applies to this situation. Here we have two skaters pushing against each other. Now, When skater A and B push against each other, they feel an equal and opposite force. The force causes them both to accelerate away from each other. But skater A will be accelerated more because she has less mass. Now we're going to look at objects that are in equilibrium. It's very easy to get confused with Newton's third law when objects are in equilibrium. You need to be really careful you understand which forces you are saying are equal and opposite. So let's start with a relatively simple example. So here we have a man pushing against a wall. This is an example of an equilibrium situation. As the man pushes on the wall, there is a normal contact force pushing back on him. These forces are equal in size but opposite in direction. Equilibrium situations can be complicated. Have a look at this seemingly simple example of a book on a table. Now, at first glance, most people would say that the weight of the book acting downwards is balanced by a normal force on the book caused by the table pushing back. Those two forces balance, and so this is an example of Newton's third law. But that wouldn't be correct. Now, the reason it isn't correct is because Newton's third law applies to objects that are interacting, and what we've just said is that there are a pair of forces, different kinds of forces, acting on the same object, the book. So this is not an example of Newton's third law. To get the full story, we have to consider things a little bit more widely. The first pair of forces we should look at are caused by gravity. We have the Earth pulling down on the book because of gravity, causing a force WB. But the book is also pulling on the Earth. Now, obviously, the Earth is much more massive than the book, so the Earth isn't going to move, but there is a pull upwards caused by the book pulling on the Earth, which matches the pull downwards of the Earth pulling on the book. The second pair of forces we need to consider is the normal contact force from the table pushing the book up and the normal contact from the book pushing down on the table. So the full story is given by these four forces. WB acting downwards is balanced by WE acting upwards. The normal force B is balanced by the normal force T. Now that is actually quite complicated. So I wouldn't worry too much if you haven't got it straight away. Have a think about it, come back and review it, and we'll do some questions on it as well, which will help clarify it. Here are some questions about today's work. And you can green pen your answers using this information. And this is your final task for this lesson. Please don't forget to send a picture of your work from this lesson to Mr. Rahman by Friday the 3rd of July. Thank you.